Thanks so much. In 1882, just 40 years after the founding of the university and 20 years before the Wright brothers' famous first flight, Notre Dame student Albert Zahm built what might have been the very first wind tunnel in the United States so that he could study the lift and drag of various shapes. In 1947, Notre Dame launched the Aerospace Engineering Laboratory, which has been recognized worldwide for research conducted in its low turbulence, subsonic, supersonic, and hypersonic wind tunnels. Now, since 2001, Notre Dame's Institute for Flow Physics and Control, or FlowPAC, has been advancing our collective understanding of fluid dynamics and aerodynamics through high-impact research that leads to engineering solutions that are technologically viable and economically feasible. Joining us today to tell us more is the founding director of FlowPAC, Thomas Cork, the Clark Equipment Professor of Aerospace and Mechanical Engineering. It's so nice to have you here, Professor.
Yes, my pleasure.
Thank you so much. Tell us about your time at Notre Dame. How long have you been here? And what would you say to prospective faculty members who are considering joining the Notre Dame community?
Sure. So I came to Notre Dame in 1999 to fill the Clark chair. I had previously been at another university for 16 years. I came to Notre Dame with the objective of starting FlowPAC, and it originally started in 2002, and I directed it for 18 years. In terms of other faculty coming here, I would just say that I was given all types of opportunities in coming here. I mean, FlowPAC was a large endeavor, involved multi-millions of dollars in terms of buildings and facilities, and Notre Dame has just given me pretty much a carte blanche to do it, and so and I think that's what I'm grateful for being at the university, and that's what I think other faculty can find as well.
What about for students looking at Notre Dame, especially one who might be interested in your field of study?
Right. Well, we've had no difficulty in getting excellent students. Even right now, my graduate students are the best that I've ever had. I have 8 PhD students. I've had as many as 15 PhD students at one time. And they all have been excellent. They've all gone on to great careers, and so that's been a real plus. I also say that we've been very good, above the national average in attracting women in engineering, which is I think Notre Dame is a great environment to attract women in engineering.
That's great to hear. I'd love to have you sort of define some of these terms we're going to speak about in layman's terms for us. So what is a wind tunnel, just at its most basic sense? And then what does the term fluid dynamics?
Okay, so a wind tunnel, so in studying, let's say, aircraft, so normally aircraft move through still air. So what we do in a wind tunnel is we actually have an aircraft or something like an aircraft stationary, and we move the air past it. So a wind tunnel is really just a means of moving air at a high speed past a test article that could be an aircraft or any object. Fluid dynamics, I guess, comes with first defining a fluid. So a fluid is any media which its volume is defined by its shape. In other words, it fills at volume. So air is a fluid, water is a fluid, any type of gas is a fluid. And so in fluid dynamics, we study fluids, both stationary or else moving.
Good. Now, in 2018, Notre Dame completed the construction of the largest quiet Mach 6 hypersonic wind tunnel in the Western world. So let's first define what does hypersonic mean, and then how is this wind tunnel different from the one that Albert Zahm built?
Okay. The hypersonic is generally defined as Mach number greater than 5. So Mach number is the ratio of the speed of the fluid moving to the speed of sound. So Mach 5 is 5 times the speed of sound. So a Mach 6 quiet tunnel is a type of design. So first of all, it's Mach 6.
Okay.
Okay. And the second thing is a quiet tunnel is designed in a very special way. It actually follows a design that was developed by NASA in the 1980s. with a very special nozzle design that will suppress disturbances. So the idea of a quiet tunnel is to try to simulate as best as possible what will happen to an aircraft flying in the atmosphere, in which disturbances are very low. Conventional tunnels can't do that.
And I assume then that's connected to high-speed flight, and what would be the benefits and challenges of that?
Hypersonic flight has become a national interest from the point of view of defense. Okay, adversaries around the world have advanced. I'll just be very specific. Missiles that can fly at hypersonic Mach numbers. To give you an idea, at Mach 6, you could fly across from New York to LA in 11 minutes. Okay, so imagine, in trying to react to an adversary, with that short time span, it really poses a national threat. And so the interest in hypersonics has been around since the 1950s, but it has reached a peak about 10 years ago, and will continue to be. And I just want to say that we are now building the one and only Mach 10 quiet tunnel, which no one's ever attempted, and of course no one's ever built one. So ours is set to be completed in late May.
Before we let you go, Professor, let's talk just for a second about the future of flight and any plans of additional, increasingly advanced wind tunnels beyond what you just mentioned, which is very advanced.
So, I will say that we're always interested in facilities where we can do ground testing. Flight testing is very difficult and very expensive, and in terms of hypersonic flight testing, we have not had a very good track record. Okay, and so it's much better if we can sort out the issues on the ground in wind tunnels. So the Mach 10 hypersonic tunnel is one of these. That'll be one of a kind that can push the boundary. There are other tunnels. I would just say that we built a suite of 3 facilities as part of a STEM hypersonic lab that was funded under the Navy, in which we also have facilities that can do high temperature flows and also study combustion that occurs in hypersonic propulsion systems. So these are all new facilities, and we just continue to kind of push the boundary in those here.
Thank you so much for your research and for talking about your work. Just a pleasure. Thanks for being here.
Well, my pleasure too. Thank you.
We will take a quick break, but don't go anywhere. We're back with Marcus Freeman up next.